In the following video, we will be discussing how reactance varies in inductors and capacitors, respectively. Furthermore, we will focus on actually defining the word reactance, exploring the mathematical means with which inductive and capacitive reactance are represented, and finally, introducing the concept of electrical impedance. To begin, let me emphasize that reactance is a phenomenon which relates to alternating current, not direct current. However, be reassured that the problem-solving techniques implemented in DC circuits are still relevant when solving problems involving AC circuits. For example, Ohm's law, which states that V is equal to IR, can be translated into V is equal to IX, where X is equal to reactance. Hence, to an extent, we can define reactance as a form of opposition towards alternating current, or the AC equivalent to what we know as DC resistance. As previously mentioned, we can mathematically represent inductive and capacitive reactance. Inductive reactance, denoted by X subscript L, is equal to J 2 pi FL, while capacitive reactance, denoted by X subscript C, is equal to 1 over J 2 pi FC. Here we must note that L is inductance in henries, C is capacitance in farads, F is frequency in hertz, while J is the square root of -1, or better yet, the value of 1 at an angle of 90 degrees. Now, let's try solving some problems. The question states that a voltage equal to 12 cos outside of 60T plus 45 degrees is applied to a 0.1 Henry inductor. We are required to find the inductive reactance in this situation. Firstly, we must recognise that the 60 in 60 multiplied by T corresponds to the 2 pi f in 2 pi f multiplied by T. Therefore, we can say that the inductive reactance is equal to J60 multiplied by 0.1, giving us an inductive reactance of J6 ohms. Recalling that the imaginary variable J is equal to 1 at an angle of 90 degrees, we get a value of 6 at an angle of 90 degrees for our inductive reactance. Finally, we are required to find our capacitive reactance in a very similar manner. Again, the key here is to recognise that 2 pi f is equal to 2000, hence giving us a capacitive reactance of 1 over J2000 multiplied by 30 microfarads. After solving this, we get a value of 50 over 3 times 1 over J. Now, the most important thing to note about finding capacitive reactance is that we simply convert the 1 over J aspect of the equation into -90 degrees. Thus, our capacitive reactance is 50 over 3 with an angle of -90 degrees. To conclude, we must realise that reactance is a formative topic which leads to the concept of electrical impedance, something which sums both resistance and reactance to find the circuit's total opposition towards current flow.